Good morning or afternoon and welcome to Pre-Calculus. Today we are talking about lesson 1.4, Extrema and Average Rates of Change. So before we can get into the average rates of change, we need to really talk about increasing and decreasing functions, because this is where it starts. Until you understand what's increasing and decreasing, we can't find the extrema and we can't find the average rates of change. So if a function is going up as we go from x from the left to the right, it's increasing. Now I like to think of it as walking up a mountain. The other thing is the slope is going to be greater than 0. Constant is just straight across level ground. M will equal 0, the slope. As we go through this, you're going to remember how to do slope, and I'm going to give you a new formula for slope. We're actually going to learn a couple new formulas throughout the course of throughout the semester and this course. Okay, and then decreasing is negative slope going down as we travel from left to right. So M is less than or equal to 0. Well, not equal, less than 0. All right, so let's take a look at this more practically. If f is increasing, okay, on interval I, so we're only looking at some interval, we're not looking everywhere. So this is what they're calling I, from x1 to x2. This is I, okay? If and only if for any 2 points in I, a positive change x results in a positive change in f of x. So when this is positive, okay, so I went up, I added something, then this is also positive. Now, if it's decreasing, as I add a positive change here, I'm going to end with a negative change. And then when it's constant, okay, when it's constant, as I do a positive change in the x, I'm going to get no change in the y, okay? 0 change. From here to here, there is no change in the y. All right, so let's take a look at this example. We're going to start and look at this graph and decide, where is this increasing and decreasing? Well, this appears to be going down as I go from left to right, all the way to this point. So there's a change here. And then afterward, it appears to be increasing. So to check this out, we plug in numbers and we actually do an XY table. So we're going to start 0, 1, 2, 3, 4. Okay, so when I plug 0 in here, I get 5. If I plug 1 in here, I'm going to have 2 times 1 is 2, minus 8 is negative 6, plus 5 is negative 1. If I plug 2 in here, this is negative, or this is 8 because that's 4 times 2, 8 here, minus 16. So I'm going to have 8 minus 16 is negative 8 plus 5. This is going to give me a negative 3. And if I plug 3 in here, I'm going to have 9 times 2 is 18. And 3 times 8 is 24. The difference between those is 6, and so I'm going to have a negative 6 plus 5 will give me negative 1. And in the same way, I am going to end up with a 5 for my number 4. Now, if you notice here, from here to 2, I'm decreasing. That means my value is getting smaller and smaller. And then from 2 all the way up, I'm increasing. Come on. Egg. My pen is interacting very funny. All right, and if I were to keep going in these directions, you can see that the pattern would continue. So this is how you would use a table to show increasing, decreasing. Go ahead and try this example. All right, so I'm not going to make the table, but I will show you what should be happening. So from here, at this point, all of this should be increasing because as I go from left to right, I'm going up a hill. Then from this point forward, all of this should be constant, and you can see here it would be constant at this value. Now there is a mistake here in this part. It's probably in your book as well. This should be negative. That way these two numbers match up. Otherwise, we are in a place where there is no definition from here to here. So I believe they meant negative 3.1. But you can see this will give me a line and this will give me a constant value. All right, so a maximum, here's the picture of it. We'll show words about it in just a second. A maximum means that for some area around it, it is the highest point. A minimum is also true. For some small neighborhood around it, it is the lowest value. Now, if you look here, this is curving like this, kind of like an upside down U. And this one is also curving, kind of like an upside down U, or a right side up U. This point is where the curves change. Where the curves change is called a point of inflection, the change of a curve. Okay, so right here is a point of inflection because my curves changed. Now, I might actually argue that there's two more points of inflection here, but this is the example that they're giving you. All right, so a relative maximum of a function is the greatest value f of x can attain on some interval in the domain. So if I had an interval from here to here, this would be my maximum. From here to here, this would be my maximum. Now, if I want the absolute maximum, the greatest it can be, then I have to take the entire domain, all of it, and find what is the highest value I can get. So this one is the absolute maximum, but they are both maximums in their own right. And then we can do the same with minimums. A relative minimum is a lowest point it can attain in a certain interval. Okay? But the absolute minimum is the value where f of x is always smaller than every other value as long as x does not equal that value. One thing I do want to note here, if you were trying to find the absolute maximum of this one, this goes on for forever, and so it would be infinity. So this has no absolute maximum. In the same way, this goes down forever, all the way to negative infinity. So there is no absolute minimum. All right, so we need to classify the extrema for the graph of each function, then support the answers numerically. So if I'm going to look at this, it looks like I have a point here, I have a point here, and I have a point here that are extrema. So this and this one would be maximums, and this would be a minimum. So let's go ahead and write. I think I'm going to have a maximum for x equals negative 1.5 and for x equals 1. I think I'm going to have a minimum at x equals negative 1/2. So now, in order to support this numerically, I actually need to make a table. X, Y, and I'm going to start at negative 2, negative 1.5, negative 1, negative 0.5, 0, 0.5, 1, and then 1.5. Okay, now notice I have included the values I thought were important. Okay, I have also included a number on either side of them. Now I need to fill out what this graph is going to be at each of these values. Okay, so right here's my function, and if I plug 0 into this function, I'm going to get everything zeroing out. Okay, and if I put 1 in this function, I'm going to have -1 minus 1, so that's -2, plus 3, so that's +2. No, so sorry, +1 plus 2, which is +3. Now, I am going to plug a -1 in. Here, this will be positive, and so I'm going to have -1. This one will be negative, so negative, negative will be positive. -1 plus 1, those just go away. So then I have this one, which will be +3, and this one, which will be -2, and so I will end up with a 1 here. And then plugging a -2 in, this one is going to be 2, 4, 8, 16. So this is going to be -16 plus 8, so -8, plus 12, so +4, minus 4, that will give me 0. All right, so now for the halves. For these, I'm going to have to plug it in. F of 1/2. Okay, if I put 1/2 in here, I'm going to end up with a -1/16 plus, because, nope, it's going to still be minus, and then 1/2 cubed will give me 1/8. And then plus 3 times 1/4, so plus 3 over 4 plus 1. Okay, so as I plug these in, I am going to have, let's see, this is 8/16, so -7/16, -7/16, and this is going to be, so this is -7/16 plus, well, this would become 12/16 and 16/16, so 12 and 16 will give me a 28/16. And so I'm going to get 21/16. My pen is really acting funny today, and I'm not entirely sure why. Okay, 21/16, this was for here. 21/16. Okay, let's see how that does. And then we've got to do the same with -1/2. And at this point, I'm kind of going to just guesstimate. I'm going to use the graph. You guys, when you're doing this, should use your calculators, but I don't want to take up all your time in doing the calculators. So here I'm going to end up with about a 2. Okay, this one's going to be about a 0. Well, about a -1/2. And this one at 1.5 is going to be about 1. All right. This is how you would do it And you can see here that this is increasing. It goes from 0 to 2 to 1. And then here it's going from 1 to negative half back to 0. And then it's going up to 3 and back down. That's how I can see my maximums and my minimums. Go ahead and think through 2b. It may be useful for you just to consider this. And remember, you have to include points on either side of these that would be your extrema. All right, so the average rate of change between any two points on the graph is the slope of the line through those points. So if I'm dealing with a curve like this, and I'm trying to estimate what's going to happen right about here, the easiest way to tell is to get the slope of the line of the 2 points that I know and guesstimate from that. Okay? Your error, there will be error, and it won't be exact. But this is the secant line. It touches the curve in 2 places. Okay? You used to know the secant line touched a circle in 2 places. Well, now we're just using secant as touching our curve in 2 places. And a circle is really a curve. Okay, and so then the average rate of change is this slope formula. And if you think about this, this is the same as y2 minus y1 over x2 minus x1. The function values are the y values. All right, so let's try this one. I am going to do A, and then you guys can do B to test out your knowledge. All right, so in this problem, I have 2 and 3. So I need to find the slope through 2 and 3. So I'm going to say 3 minus 2 on the bottom. Then I need to find f of 3 and f of 2. So f of 3 is going to be 3 cubed is 27 minus 3 squared is 9, 18 for the times 2, minus 3 times 3 is 9 plus 2. Well, this is very simple here. All of this equals 0. So then I just have the 2. F of 2 equals. So now that I'm doing this one, I'm going to plug 2 in here, and I'm going to get 8 minus 8 minus 6 plus 2. Well, again, this part goes to 0. And then I have negative 6 plus 2, which gives me a negative 4. So now I need f of 3, which is 2, minus f of 2, which is negative 4. Be very careful and don't forget the negative inside and outside. It's a very common mistake and is one that will cause you to suffer here because these two go together to make a plus. So then on the bottom I have a 1, and on the top I have 2 plus 4, which is 6. So my average rate of change is 6. Try this one. Now, sometimes when we're working these problems, we don't necessarily see an application for them. As I alluded to earlier, you do use the secant line to estimate what will be happening in the future and what happens between the 2 points. Notice here, from this point to about here, the secant line and the graph are very close. So this really does let you estimate what exactly is happening in that region. And sometimes we don't have the graph, or we don't understand what is really going on behind the scenes. So we use these kind of estimations to try and guess, and this is just one of the estimations that we make. We often will try multiple different estimations with different curves to try and guess what is happening. So in this problem, they were given the height equation. We don't always have the equation, but they were given the height equation, and then they were given 2 times. They had to plug it into the equation, simply find the slope, and this is the speed, because the slope of a position versus time graph is speed. And so the average speed is negative 18 feet per second, because h of t, t is time in seconds, and height is this h of t. So, and it's in feet, so that's feet per second. And because it's negative, we know it's falling. Kind of interesting stuff. The same would be true here. You can go ahead and try this one. The distance in feet, okay, so we've got feet again. An object traveled when dropped from a high place is given by this, where t is the time in seconds. So we're going to have feet per second after the object is dropped. Find and interpret the average speed of the object from 2 to 4 seconds. So you plug 2 and 4 into that equation and find the slope. Your homework is on Alex. Go ahead and complete that, and you will have your Chapter 1 test on the 5th.